Can we make this contraption move? Yes, we can. In case you're wondering what this thing is, it is a very simple one-axis Piezo-Nanopositioner using the stick-slip motion principle, and it's working. This was inspired by the open-source Nanopositioner project and the corresponding videos of it on YouTube. The first time I saw it in action, I was completely mesmerized. While I had no immediate need for a nanopositioner and I had no idea how it actually worked, I couldn't help but to immediately add it to my bucket list of things to try out, and here it is. Interestingly, besides the demonstrations by the original author of the open source project, there weren't many people attempting to replicate it. I found only one video on YouTube where someone has replicated the design, and yet he couldn't make the stage to move at all, hence the word challenge in the title of this video. By the way, here's my first attempt with this design, and it also failed to move. That thin stainless flexure was the problem. The design is remarkably simple. One end of the PZT stacked actuator is epoxy glued to the carriage of a linear rail, while the other end is glued to a small N42 magnet. For this simple design to work, the linear rail needs to be magnetic, and thus it has to be of carbon steel, not stainless steel. Sadly, the carbon steel linear rails are getting harder to find. The PZT stacked actuator is from AliExpress. I have originally chosen this Apex PA88 high-voltage amplifier, thinking that I would need to drive the PZT with something like 200 volts or more. Yet the design works fine with as little as 40-volt peak. The only caveat is that these stacked PZT actuators have high capacitance. This little one is already 0.1 microfarad. The amplifier output current needs to be high enough to drive this capacitor across the entire voltage range in as short as possible time. The PA88 amplifier is just barely making it with its 100 milliamps maximum output current. The triangular-shaped driving signal can be generated with any suitable digital-to-analog converter. Amazingly, this tiny stage can move a lot of weight. Vertical application is possible, but a bit more challenging. A somewhat larger magnet would have likely helped here. Thanks for watching.